Welcome to section 1.2, observational studies versus designed experiments. So we're still in our process of statistics where we are collecting our data. So now that we know what to call the different types of data, those definitions and how to measure them, we're going to talk about how we can actually get data. So we're going to talk about observational studies primarily, and we're just going to define designed experiments, but we're going to focus more on observational studies. Okay, so let's use this example. Let's say we collect data to determine if the explanatory variable has an effect on a response variable. All right, so I'm going to underline or highlight those. So we collect data to determine if the explanatory variable explains how another variable responds. So for instance, data can tell us if smoking increases rates of lung cancer. And we can collect data in two ways. Observational studies, where we just observe smokers and compare cancer rates maybe to non-smokers, or by experimentation, when we control everything. We control the amount of smoke exposure, and then we compare the cancer rates. All right, so the observation is called an observational study. It measures the value of the response variable, so in this case, the lung cancer, without attempting to influence the value of either variable. That is, in an observational study, the researcher just observes the behavior of the individuals in the study without trying to influence the outcome of the study. Pros and cons. So the pros is that this is fairly easy to do. So pros, fairly easy. And when we say fairly easy in this world, it means it doesn't take a lot of time and it's cheap. So fairly easy means fast and cheap. All right, and the reason why is we're just observing. We're not trying to control the variables. So fairly easy means relatively quick and cheap. The cons. So the cons is because we're just coming in and observing what we see. So one of the big ones could be unaccounted variables. And we'll talk more about that in a second. But other unaccounted variables could be messing up our study. It could affect the outcome. It could affect the response variable. So with these other unaccounted variables, in any observational study, because remember they're unaccounted, it's hard to tell if the explanatory variable, like smoking, is actually causing the response variable, like lung cancer. So if we have an observational study, our conclusion has to reflect this. So we are not allowed to say in an observational study that smoking causes lung cancer. We can only claim association. So our conclusion would say something like smoking is associated with lung cancer. Or maybe we would say with higher cancer rates, something like that. Okay, so that's a pretty big con. So let's come on over to designed experiments. So if a researcher assigns the individual in a study to a certain group, intentionally changes the value of the explanatory variable, so controlling how much maybe someone smokes or doesn't smoke, and then records the value of the response variable for each group, the researcher is conducting a designed experiment. All right, so let's do our pros and cons. So pros, a big pro is that because the researcher is controlling everything, so for instance, if we're talking about the smoking example, that means the researcher is controlling everything that could also contribute to lung cancer. So maybe they're controlling the diet, they're controlling the amount of exercise they live. Somehow they're grouping them together with similar genetic makeups. And then they're telling them how much they can smoke. Maybe some people smoke 5 packs a day. Maybe some people smoke 1 pack a day, and then other people don't smoke at all. And when you control the environment like that, now you can claim causation. Smoking causes cancer, for instance. And then now a con. Did that sound bizarre, what I was just describing the researcher having to do? Having to control every aspect of someone's life? It is weird. It's unethical. So that's a huge con of designed experiments, is they're unethical, because either they're controlling a human, or if that's not available, they're doing some sort of animal testing to get the same results. So unethical is definitely a con of a designed experiment. Not all designed experiments are unethical. For instance, I could make an experiment. I wanted to know what fertilizer worked best on a plant. If I don't fertilize a plant, that's not unethical. So only sometimes is it unethical. Controlling environments is expensive. And sometimes you have to wait for the response variable, so it can also be time consuming. It can take years to develop cancer. All right. So going back to our observational studies, when we were talking about those unaccounted variables right here, we have a name for them because it is an important part of observational studies. And that's what we're going to define next. Those unaccounted variables, they can be called lurking variables, and they cause confounding. So here's our next definitions. Confounding in a study occurs when the effects of 2 or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable, it can be due to some other variable or a variable is not accounted for in the study. All right, so that's why it's important when you're doing observational studies to take things like lifestyle into consideration and try to weed out as many explanatory variables as possible. All right, a lurking variable is an explanatory variable that was not considered. It's lurking in the background, but it affects the value of the response variable. Lurking variables are typically related to any explanatory variable in the study. And then finally, a confounding variable is an explanatory variable that was considered in the study, whose effect cannot be distinguished from a second explanatory variable in the study. Okay, so because of this verb confounding and the 2 variables that cause confounding, that's why we only claim association for those observational studies. All right, so more on that in our example coming up. But for now, let's look at some more definitions. Again, we're focusing on the types of observational studies. And the types have to do with the present, past, and future. So a cross-sectional study, we can write these before we actually look at the definitions. This is a present day study. Case-controlled study or retro studies have to deal with the past, and then cohort studies deal with the future. Okay, so let's look at those definitions. So cross-sectional study, collect information about individuals at a specific point in time or over a very short period of time. So this would be in the form of a survey. And for our smoking lung cancer example, it could be something like, do you smoke? Yes or no. Do you have cancer? Yes or no. So again, it's about a specific point in time. So some pros, this is good. Again, it's quick and cheap. Surveys don't take that long to fill out. So that's a good thing. A bad thing is, let's say this happens. I go to a cross-sectional study, let's say I smoke. I say, yes, I smoke. And then I leave the study, and then 2 months later, I find out I have lung cancer. So it's quick and cheap, ... but the results may change later. That would be important to the study. Okay, so in comes the case-controlled study. These studies are retrospective, meaning they require individuals to look back in time, or they require the researchers to look at existing records. And individuals may be grouped by similar traits. So in our example, let's say maybe someone's not presently smoking, but maybe they smoked like 20 years ago. So that takes care of this fact up here. So maybe a current smoker later has lung cancer. Well, case control, since it's retrospective, we can look at past smokers and their rate of lung cancer. All right, so the question now isn't, do you smoke? It's, have you ever smoked? Have you ever had cancer? So some pros to this, again, is that it's quick and cheap, just as before. And now, while we may have the future part later that the results may change later, sometimes individuals forget the past. I forget things all the time. So individuals may forget the past, or maybe records have been destroyed, something like that. And that would affect the study. So that's a pro, and then right after is the con. Okay, a very strong type of observational study is the cohort study. These studies are prospective. It means, like, in the future, the data is collected over time. Individuals or cohort participate in a study over a period of time. So this is our most powerful observational study because it deals with the two cons from before. If the results change later, that's okay because it's a cohort. We're following them into the future. Individuals may forget the past. That's okay because we were with them in the past. So we've already recorded all the information. So this is our most powerful observational study. But, of course, there's always a con. It's no longer quick and cheap. It's more expensive. It's more time-consuming, since we're following them around for years. And if we're dealing with humans, humans have free will. They're allowed to drop out of the experiment, either willingly or maybe illness or death, something like that. So individuals may also drop out. All right, so we have some pros, we have some cons. So let's practice our definitions. Feel free to read this on your own. Pause and let's see how you guys do. All right, so researchers want to determine if there is an association between the level of happiness and the risk of heart disease. The researchers studied people over the course of 10 years. During this 10-year period, they interviewed individuals and asked questions about their daily lives and hassles they face. These interviews were videotaped and studied to assess the emotions of the individuals. The researchers also determined which individuals in the study experienced any type of heart disease over the 10-year period. After the analysis, the researchers concluded that the happy individuals were less likely to experience heart disease. What type of observational study is this? Well, if they follow them around for 10 years, It has to be a cohort study. All right, they were studied over 10 years, so studied over the period of 10 years. What's the response and explanatory variable? Well, we'll start with the explanatory variable. Whoops. And it's based on how the study was set up. So, let's see. The researchers concluded that the happy individuals were less likely to experience heart disease. So how that's set up, they're saying if you're happy, less likely to have heart disease. So the explanatory variable is level of happiness. Explanatory variable, I'll write it right here, is level of happiness. Don't just write happy, it has to be the level of happiness. And then the value of that variable, one value could be happy, one value could be sad. And then the response would be risk of heart disease. High risk, low risk, no risk. Those are the values. All right. And again, in a different study, these two variables might be switched, right? Maybe the response variable is level of happiness, explanatory variable is risk of heart disease. But just how they concluded the statement, that's how we figured out which one was which. In the report, the researchers stated the research team also hasn't ruled out that a common factor like genetics could be causing both the emotions and the heart disease. So using the vocabulary above, what does this sentence mean? So, we could say something like genetics could be a confounding variable, or genetics may be causing confounding, something like that. So genetics is a confounding variable since it's identified, but they can't separate it. Or we can say genetics is causing confounding. Something like that, but get that word confounding in there. All right, so one more example for you guys. Go ahead and push pause for this last example and come back and check your solutions. Okay, so we want to determine if having a TV in the bedroom is associated with obesity. So what type of observational study is this? Well, the researchers administered a questionnaire and they asked about their BMI and if they had a TV in their bedroom or not. So this was all about the present. They didn't say, have you ever had a TV in your bedroom? What has been your BMI the last 5 years? So this is a cross-sectional study. The explanatory variable is whether or not there's a TV. The values would be yes or no. Yes TV, no TV. And the response is the BMI. BMI is body mass index. It's a ratio, more or less, of your height and weight. Okay. In the report, the researchers stated the results remain significant after adjustment for socioeconomic status. So that means they somehow were able to separate socioeconomic status from the other variables, whether or not there's a TV in the room and the BMI. All right, sometimes you can do that by grouping them in those like homogeneous groups. So what does this mean? We could say that they were trying to prevent confounding. They were able to separate those explanatory variables. So we could say something as simple as, what does this mean? They were trying to prevent confounding. They thought socioeconomic status might be a confounding variable, but it wasn't. The results remained significant after adjusting for that. Finally, can we conclude that a TV in the bedroom causes a higher body mass index? Well, remember, this is an observational study. And observational studies, we cannot claim causation. We can only claim association because it's an observational study.